Well, that was interesting. This is the second part of the first lecture. I'm sorry I got cut out there in the middle of my discussion. It's the first time I've had that happen. Zoom kind of crashed on me and tried to rejoin and wouldn't do so. So I'll have to post this, I guess, as two separate parts. But this is still the system administration course. We still have a little time left and a couple lessons to cover. So let's see if we can pick up where we left off. I'm sorry about that. So we were finishing up with lesson 3. We'd gone back and talked about some of those other components that I almost missed. And so that leaves us moving on to lesson 4. Lesson 4 is about all the different operating system families out there. And it's very important that you understand and know these, and because you're going to, once again, have to very likely face and support defending and the different devices and different types of things in all of these different families. Most large organizations these days have a mix of stuff in their organization, one way or the other. At least a couple of the families, if not very often all of them. So what are the various families? Well, the one most people are probably familiar with, just because it still is the dominant share on the home and corporate desktop space, is the Windows family. Microsoft Windows is currently at Windows 10, and technically, we'll see if this happens, but technically it's going to stay Windows 10 forever, and we're all just going to get updates. They've kind of taken a page out of the Mac OS plan, and instead of selling it as a separate product, it's now becoming a platform on which they build, and ostensibly just comes with your computer now, or you upgraded for free from 7 or 8 back in the day when you had the chance to. 10 is a whole family of operating systems. There are versions that are stripped down that only run on, say, an embedded system. Powering the embedded systems or the new Internet of Things, as we've talked about. There are also server versions of Windows that are in existence. And even though the current versions are Server 2016 and are the most recent, and Windows 10, I think Creator or something edition, Creator was the last big one I remember directly. We get automatic updates, and so admittedly I don't quite pay as much attention to my Windows 10 boxes, probably I should, but I do most of my work in VMs anyway. But one of the things you need to keep in mind is that the family is older than that. Obviously, it has a whole history all the way back to the original DOS computers and the early versions of the bolt-on Windows for work groups, and then moved into Windows 95 and 97 and on and on. But lots of all of that, of course, is old and no longer really being used, or very, very rarely. But you will run into some of the older versions of Windows still in place. And particularly, surprisingly, you will still occasionally run into Windows XP. Windows XP has been expired now, has been end of life, discontinued support, etc., for a number of years, but it is still out there. And the reason is because it was very popular in a number of different niche industries. One that jumps to mind immediately is ATM machines. Most of the ATM machines you go to these days, still to this day, and you put your card in, you get a little cash out, it's very likely a Windows XP machine in there. And so the reason that is still happening is that some of those manufacturers and providers have paid Microsoft huge amounts of money to continue to develop updates just for them, because they are not in a position to upgrade yet. They don't feel like changing their entire infrastructure of thousands of installs. There are point of sale systems like this. There are other types of embedded systems that are powered on XP. So you will run into XP. It's something that definitely needs to be, if it's not part of some big companies' paid support program and still getting updates, and even if it is, since it's so old and vulnerable, running it in a sandbox type of environment, isolating it on network segments, etc., is very important aspects to keep in mind. But even beyond XP, other versions like Windows 7 is about to go away. I don't know its exact date, but I believe it's coming up when it will be discontinued, but that will still leave Windows 8 and 8.1 that'll be out there. Now, 8 never got a big install, and so there's not a lot, but there's a lot of 7, because a lot of the corporate world hasn't made that switch to 10. They have stayed on Windows 7 Enterprise, for example, and tied into their networks. And we also see a lot of the older, honestly, you will see in smaller organizations or in niche applications or places where something's a legacy system, you will still see Windows Server 2003 machines out there. That's a long time ago. 2008 for sure. 2010, 12, 16, the newer ones, of course. But so there are a lot of different versions of Windows. There even for a while was a Windows Phone, even though that's kind of gone away. And of course, Windows in one form or another of its family powers things like Xbox and the Surface tablets and other types of devices. So there's a whole family, both of the current as well as some older versions you need to be aware of, because there are many times that's how things happen. One of the last times that Microsoft actually pushed a patch out for XP, and they have done it actually even for people who aren't paying that high-end support contract, was some of these encrypto viruses that have come out. So when they came out and they were taking advantage of an old hole in the Windows operating platform, even because Microsoft is aware that, especially in other parts of the world, less developed parts of the world, that XP is even more prevalent still. They realized that that was important for them and for their own image, even though that's out-of-date software. They went ahead and patched it to try to fix and take advantage and take that vulnerability out, so that would not spread in the WannaCry and some of those viruses. So you will occasionally see those older systems. Windows machines share a common underlying infrastructure now, the modern versions, and they have a whole legacy of system. I actually have become a big fan of Windows 10. It's just a desktop operating system, even though I'm not a big fan of all the information it gathers. That it seems to be taking a page out of the Android playbook of gathering all kinds of information on us as users now. But then after you go from Windows, the next most popular desktop, which is admittedly a fairly small share, but it has grown somewhat in the last few years, is Apple's products. Apple has what they call Mac OS. Previously it was called OS X or OS 10. It's in Roman numerals, and they have stayed with the same name now. They stayed with OS X for quite a while, and then they switched recently to Mac OS. And they have a whole series of operating systems that are all use the OS as part of their name. So for their laptops and machines, they have Mac OS. And then, of course, for like their iPhones and iPads, they have iOS. And then for their Apple TVs, they have tvOS. And then for their watches, they have watchOS. So they have a whole line of families, OS something. But they all share a number of things, and they have been moving toward making their platform more and more consistent. There's talk that in future you might be able to run iPad apps on a Mac and things like that, and then the functionality of the more powerful iPads and tablets will be able to potentially someday take on some of the more full-featured Mac software even. And the apps are already getting very powerful as it is, so we'll see how that all goes for them. But they, of course, have their own look and feel, their own GUI desktop. But at the core, actually, underneath, if you dig down deep underneath all the Macintosh, they're actually Unix-based operating systems. The only reason they're broken out as a separate and not lumped into our third family at the end here is because they really are unique, especially on the graphical side. They have their own unique interface and look and feel. And the other part is just the integration, because the one thing that they have that none of the other families have is they also incorporate the hardware into the family. You can't just go out and buy a copy of Mac OS and throw it on an Intel computer, theoretically, even though Macs themselves run Intel chips. They have things kind of locked down. Even from a virtualization point of view, it is technically not legal to run a virtual Macintosh on a PC computer using VMware or VirtualBox or something like that, because according to Apple's license agreement, you have to run their software on their hardware. Now, I own some Macs. I am cross-platform across all of it. Linux servers, Windows PCs of all different ages and types, lots of virtual machines, and I've built virtual Macs. But the only way to do that legally is to do it on a Mac. So, well, since I have a Mac, I can use VMware Fusion or VirtualBox to build another virtual Mac for testing and playing. But technically, it's only legal if you run it on Mac hardware. It can be done on the others, in all honesty. It's a little bit of a hack, but the reality is, from a legality point of view, you can't. And that's the thing about Apple that does make them unique, is that they control both sides of their whole ecosystem. They control the hardware, and they control the software, including the operating systems, and then only then can apps run on top of that. Whereas, of course, Microsoft controls the Windows platform, but Windows runs on all kinds of different, AMD, Intel chips from all different kinds of manufacturers, including you running up yourself to your parts store and buying a motherboard and buying a chip and building a PC from scratch. And then you install Windows on it and it works. And you can do that. The last family, of course, is the Unix or Linux family, the NIX family, asterisk NIX. The Unix machines you will run into them in some organizations, powering powerful workstations, maybe even little mini computers. You will run into the true Unix occasionally. But the reality is most of what you're going to run into today is the Linux world, the Unix-like operating systems that have spun off of that, including things like FreeBSD, Berkeley Systems Design version. That's another Unix-like operating system. And of course, within the Linux world, there are just so many countless flavors, it's almost impossible to keep track of. And they can be found to run on all different kinds of architecture. Years and years ago, when Apple had its own chips that it made in partnership with Motorola and IBM called PowerPC chips, there was a version of Linux that ran on those called Yellow Dog Linux. And of course, there's been Slackware and Red Hat and SUSE and all kinds throughout the years. The most popular, seemingly today, is Ubuntu, a very common Linux distribution, Debian-based distribution. And so once again, there's some similarities. And one of the things I love is that at least at the command line, the vast majority of commands transfer. So if you've learned LS and all that basic stuff we've been teaching you from the Network Foundations, and you're going to get to play more with in the upcoming classes, then that carries over into just about every flavor. And the specific applications that run on a Sun Solaris or IBM Unix system or HP Unix system versus what run on Linux, they could be different, obviously, but the actual underlying ability to use LS and CD and present working directory more and less and grep and all these utilities, for the most part, if they're installed, they're going to run pretty much the same way on all versions of Linux/Unix. And so once you've learned kind of the basics of Linux/Unix, then if you get thrown down into a computer, you can probably do some things on it that you might not realize, even though you've never used that version before. I remember I loved when Apple moved from their old proprietary OS to their Unix-based OS of today, OS 10 level and above, because all of a sudden I could open up a terminal on a Mac and do things that Mac users for years, way better Mac users than me, didn't know was possible because they had never had to deal with a command line. And so nowadays that's changing as Mac does have that underlying Unix kernel. But those are our three major families. We have the Windows world, and of course where we mainly see that is on desktops and on Office type of servers, of course, like Active Directory and file and print servers and things like that. You will then find Mac, and they're mentioned not only because you will find them occasionally in the corporate desktop, or occasionally somebody has one, whatever the percentage is exactly, but it's a smaller percent than Windows by a long shot. But you will potentially have to support or be aware of a user bringing in their own Apple laptop onto your network and what that could mean one way or the other. But even more importantly, possibly, is the devices. A lot of corporations in these days, given the way the smartphone market and tablet market has moved, is they've moved away from providing the phones to their employees to just saying bring your own device. And then they have to use some kind of mobile device management system or solution to help manage that. So you need to be aware of Apple. And for those type of things, even if you never work with an Apple Mac, you may have supporting a bunch of users who are on iPhones or using iPads in meetings, etc. And so we have Windows dominating mainly the desktop space, Apple being one of the dominant players in the mobile and device space. And then the Unix Linux world, we have to be aware of it for two reasons. One is that the vast majority, funny enough, even on Microsoft Azure cloud platform, the vast majority of stuff that they are running are Linux servers. The vast majority of internet servers are Linux servers. The vast majority of websites in the world are Linux servers. And that's because Linux is free and is open source. It's, has its issues, but it's obviously fairly secure, very powerful multitasking operating system. And so you will find that, of course, the vast majority of public websites that you access are running Linux out there. But also a lot of the things, like many times, most of you probably play some kind of game on your phone. If it sends data back to the server, like even if it's just high scores, let alone if it's a multiplayer game or something where it's always constantly transferring data to keep you updated what's going on, where your enemies are, your buddies are. The reality is most of the time those games use web servers, believe it or not. You may not have realized that. But if you think about it, that your game probably works at Starbucks Wi-Fi, it works at home, it works on your friend's network, it works when you're at the office. Well, how does that happen? Your office got firewalls. Aren't they blocking that? Well, that's because most firewalls do block a lot of stuff. Most game and application web and Android, iOS, it doesn't matter. They actually use port 80. And so there are literally, I don't know what the numbers are. There may be multiple times more web servers that no one ever goes to with a browser. But their purpose in life is to take requests from apps, and they used HTTP and port 80 to send that data and then get the update from the server. It comes back in. And even though it's not actually a web server per se, or like serving web pages, and it's not actually a web client, you're not browsing with the Safari browser or Chrome or something, you're playing a game, but it's using port 80 and it's talking. And so on one hand, you got to keep track, you got to know Linux and the Unix world from the servers, because that's where you'll run into them, either on premises. Somebody might still have an old IBM mini computer running AIX Unix, and you need to be aware of that. Or of course, most of the stuff that's being spun up in the cloud is Linux based. So the other side of that, though, is, and this is something you may or may not know as well, but the largest installed base of Linux anywhere now is Android. Android is a Linux-based operating system, specifically written for mobile phones, of course. And there's both the open source version that was originally created by Google and is still an open source project supported by them. But then there's the sort of full-on Google with all the Google stuff rolled into it that they continue to put out and give out to phone manufacturers, etc. But even Kindles, they're based on Android. The Kindle OS, Fire OS, as they call it. I own a Kindle as well. I think I own just about every toy there is. That is a Linux-based OS because it's an Android-based OS. They stripped out all the Google stuff. They took just the open source part, just the operating system part, and included their own store and their own stuff into it. And were able to do that because it's open source, and you can make your own derivative from that point. So they have their version for Kindles, and Google has the main version that it provides to most providers like Samsung and other people. And then there's just the open source product as well. But all of that was based off of Linux and then turned into this operating system. So if you can actually open up a terminal on your phone, if you have an Android phone, and you can type ls, and you can take a look and see a similar file structure, a little different because of the mobile device, but that's a whole different talk show I won't get into. But once again, your need to understand these different operating systems is to be aware of them from a support and securing point of view. And one of the things that you'll see that is really just for your reference, but something to be aware of, is there's links to the vulnerabilities, sample vulnerabilities, example vulnerabilities that have been found in these different operating systems. And those are good places to have bookmarked for future, because you'll want to keep up when a new vulnerability comes out and it affects an entire operating system. And obviously, if it's a big one that opens a risk into your network, you're going to want to fix it. And so staying up with those sites and that data becomes very important. Now, we're running out of time. We lost a few minutes there due to the disconnect, and it told me it was, like I said, the Zoom told me it was reconnecting and then never would go back into the room, so I just had to start over. I will post this as 2 parts, I guess, when we get done. But nonetheless, I guess part 1A and part 1B or something like that. However, I'll get it done, and we'll get the links up for you later tonight. The last lesson, and I'm just going to hit it high level to begin with, and then we'll start with it with some demos and stuff next week and some examples, is what we call shell scripting. Shell scripting is basically programming, and I'll just say that up front. I'm not trying to scare you away. It's not that difficult, but you are going to learn some programming as part of this program, and this is your first experience with it if you've never programmed or scripted before. It's shell scripting. Shell scripting is hugely important to system admin, and to be honest, it's hugely important to us in security as well. We will see either scripted attacks against us, or we may have things that we do to script as part of defense or as part of analysis after a potential attack. And so, and I can actually tell you, Like has been mentioned, this program is meant to get you entry-level job in the program in the field and to get you more than enough to take the Security Plus. Well, I actually just took their new Pen Test Plus, CompTIA's Pen Test Plus beta exam. It won't even be available to the public until August, till January 31 or July 31 of this year. And I was one of their beta testers, and it asked questions on scripting right out of this lesson. Basically, basics of, how, and you need to be able to at least read a script to interpret it and answer questions. And they actually go further than that, and they have some questions that are on Python and Ruby. And we obviously cover Python later in this program, and there was a reason for that. I feel very vindicated that they added that to the pen test. I just knew when we designed this program, we had to go more than just their objectives for Security Plus and give you an exposure. And so we're already beginning to set you up for this next tier of certifications, even in this program. So what is shell scripting? Well, ultimately it's programming. So what is programming? Well, ultimately that's just giving a series of instructions to a computer so it'll do something for you. Doesn't sound that bad, does it? Well, the challenge is you have to do it in a language that the computer can understand. While we may have Siri and Alexa and we can say some basic things like what's the weather outside, we don't have Star Trek level of artificial intelligence where we can sit down and just have a discussion with the computer and bounce the ideas back and forth and say we want this data divided by that data and calculated and correlated by this. We can't do that. They're not that smart, and they may not be for still some time, even though they're rapidly and seemingly improving, but they're doing it in very narrow areas. So at least so far. So we don't have that interface. And so, of course, if somebody's already written a program, like a database program, we can go in and do some queries. We can use that, those skills, that language, those tools to do that. But if we really want to talk to a computer at its lower level, we want it to do a series of things for us. We want to particularly automate a lot of, say, system administration, or in our case, security type tasks. We could use shell scripting. And basically, shell scripting are simpler languages. They still are programming languages, but they are simpler and they're tied into the OS in one form or fashion, the operating system you're using. So we'll be learning about Bash, which is actually the born-again shell and the scripting language that's built into that shell, which is the default shell for almost every flavor of Unix and most Linux. Even it's the default shell on Mac. So Bash scripting works there. Or we're going to talk about PowerShell on the Windows side, which is a scripting environment that they came up with integrated with the OS. And these are important things because, well, let's just take it from a system admin point of view. If programming in general is giving a whole series of instructions to a computer in a language it understands so it can give you back what you want, whether that's output of data or it's a game or whatever you're writing as your program. When we talk about scripting, we're talking about a subset where we're trying to issue like operating system level commands. And generally speaking, it's a series of commands. We could have literally gone down and typed one after the other at the command prompt. So like in last class, Network Foundations, you learned how to use the user add command to add a user into Ubuntu. And you probably have learned from previous experience or courses how you could either on Windows going into that, the control panel applet of the users, or if you're a full network using Active Directory, you would go into the Active Directory user and manager tool and you could add a new user, click new user, fill in the dialog, or you can say user add and give it a name and start typing things and do it at the command line. And you can do at the command line with PowerShell. You could create a user, whether a local user or a network system user, Active Directory user. And that's great. And as a matter of fact, many times people may learn from the GUI to begin with, like especially in Windows networking, they'll teach you how to do everything at the GUI first, and then begin to teach you the command line. And the reason for it is because it's usually faster. It's more efficient. And so for example, if nothing else, if I had to go in and add 1,000 new users, then I could use that GUI in Windows, Active Directory users, and click add, fill in the dialog, save, click add, fill in. But if there's a command, and then of course, remember we have the up arrow and tab completion and stuff like that, I can probably issue that command faster, just typing it all in once I've got it learned and memorized. Then I could filling in that dialog. And better yet, if I have to do 1,000 users, instead of having to do them all one at a time in the dialog or one at a time at the command line, I can write a little script that'll automate that for me. And that's where scripting comes in. Even though the vast majority of the things we could have typed character for character at the command line, we don't want to have to type it at the command line. We don't want to have to type that command 1,000 times. We want to write a little script that says, okay, for 1 to 1,000, some kind of loop. We want it to loop through until we run out of new users and just keep doing the same command. And so we have to understand the basics of programming, and you're going to then learn the basics of scripting in that capacity. So just conceptually, before I close for this session, the basics, let's take a look at that, and we'll go back over it and do some examples before we move on next week. But in every programming language, there is a syntax or the rules of the language. Think of it like speaking any language. There's rules. And so when we speak to the computer, even though we may be typing it into a console or into a page of source code, we're having to speak those rules. There are keywords we can use to call certain action, and then we shouldn't use them in any other way. There will be some kind, every language supports various ways to control the flow through the program. Like I mentioned, a loop. So we could set up a loop. So it'll loop through and do the same thing 1,000 times for us, but with slightly different information. Now, how can we do that? Well, that's where a concept, which is probably the toughest concept for people. So if you have any problems when you read through everything, take a look at it, let me know. But variables. What variables allow us to do is to use a placeholder in place of a value, and then we can change that value all the time. So for example, just conceptually, we talk about our company buys a new company, and I get a list of 1,000 users I need to create. I have their user first name, last name, and I know what username I'm going to create. Well, obviously, I can go in and cut and paste and fill in the dialogue, but I could write a script that says, okay, read this file, and for each line in this file, grab their first name, grab their last name, and and then issue in the command, add user add. It uses, instead of hard coding Lee and their name, I have to write the line still 1,000 times. Instead, I use first name, last name, username. Those are variables that I use. And that way, the program, as it loops each time, will go get a new line and update those variables, and then create that user. Loop again, pull the next line in from the database or the spreadsheet or wherever. And so that is where the power comes in. Now I've actually only had to write a few, maybe a dozen lines of code, maybe less. And it's like I can run that program, and technically it's like I just issued 1,000 lines of code. So you can see not so much code, but 1,000 commands. But I wrote a small little loop that issues that command over and over again with different information each pass, and it pulls that information from another source. So we're going to look at some scripts that do things like that. In our case, they're going to copy certain types of files from one place to another, so kind of an archive or backup script. And then you'll learn the basics as it takes you through the lessons, and then the exercises, you'll extend the functionality of that. We'll look at some other examples next week, and I will get the 2-part lecture of this posted later tonight after I get through the last couple lectures I have today. See you next week. Thanks.